Good morning to all of you. Myself Deepti Jain, lecturer electrical engineering from GPC Khuni Machra. I am here to present a lecture on conducting materials. So, first of all, let us discuss what are conductors, insulators and semiconductors one by one. So, conductors are those substances through which electric current can flow easily, and the examples of these conductors are silver, gold, copper, aluminium, etc. Now, conductors have a very large number of free electrons, and generally metals have a large number of free electrons. So, we can say that metals are the good conductors. So, we can say that conductors are those materials through which electric current can flow very easily. Now, insulators are those substances through which electric current cannot pass easily, and the examples are glass, mica, dry air, bakelite, wood, etc. And third category is semiconductor. Now, semiconductors are those materials whose conductivity lies in between conductor and insulator. Means we can say that semiconductors are those substances whose conductivity is less than the conductor and it is more than the insulator. So, in other way we can define the semiconductor as the substances whose resistivity lies between the resistivity of conductors and insulators. Means examples are germanium, silicon, carbon, etc. So, before discussing all the materials, conducting materials, let us discuss the basic electric circuit first. So, electric circuit, what is basically an electric circuit? So, an electrical device which provides a path for electric current to flow is known as a electric circuit. So, this is a electric circuit. So, this is a real circuit in which a bulb is connected to a battery through a switch. So, these are the wires which are carrying the current. So, in this circuit, these wires are the conductors because these are carrying the current. So, this is a circuit diagram. So, this symbol shows the bulb in which this bulb is connected through a battery and a switch. Now, when this switch is open, no current will flow, and when this switch is closed, then the current will flow through the circuit. So, this is a complete electric circuit. So, electricity, what is basically electricity? It refers to the presence of electric current in wires, motors, light bulbs and other devices. And what is the electric current? It is similar to a current of water, but electric current flows in a solid metal wires, so it is not visible. So, electric current can carry a lot of power. So, see, with this electric current we can do the work in minimum time. So, electric circuit is something that provides a complete path through which electricity travel. So, the path through which electricity travels, these are known as wires, and the wires in the electric circuit are similar in some ways to pipes and hoses that carry water. So, this is a diagram of pipes and hoses that are used to carry the water, and in the same there is a equivalent circuit in which these are the wires which are used to carry the electric current. So, we can say that an electric circuit is that complete path through which the electric current flows. Now, when we draw a circuit diagram, we use some symbols to represent each part of the circuit, and these symbols are quicker and easier to draw than realistic picture of the component. Like suppose this is a real circuit, and to draw this real circuit in a circuit diagram, we use this So this is the circuit diagram in which a bulb is connected through to a battery through a switch. So this is a switch. So this bulb can be replaced by a resistance. So this is a simple electric circuit now. So we can say that this wire is represented by these horizontal and vertical lines. Now this is a battery. So this is the symbol of the battery in which there is a small and the large plate. Now this large plate carries the positive terminal of the battery and this small plate carries the negative terminal of the battery. Now this bulb can be represented as this or it can be replaced by a resistance. So this is a switch. Now switch is this is a symbol of a switch. So by these symbols we can draw any real life example to a circuit diagram. So see, we have closed this switch. So at the instant we close the switch, the electric current starts to flow in the circuit. So this is the direction of flow of current from the positive to the negative. So when the switch is open, there is no any current in the circuit. Now how does current move through a circuit? So in the most simple circuit, an electric current flows in that circuit in response to the applied voltage. Now voltage is electromotive force and it will cause the current to flow in the circuit to which it is applied. Means basically the movement of current in the circuit is because of the potential difference between the two ends, or you can say it is because of the electromotive force in the circuit. So in a simple circuit with the DC voltage applied, electrons leave the negative terminal of the source and flow through the circuit, then return to the positive terminal of the source. So it means we can say that the electrons from the negative terminal of the source and it then flows from the negative terminals to the positive terminal. So we can say that the direction of the current is opposite to the flow of the electrons. So the electric current flows from the positive terminal to the negative terminal. The resistance of the circuit will determine the amount of current that flows. So again this is a circuit. So the amount of current flows depends upon the resistance connected in the circuit. Means इस करंट विच कितना करंट इस सर्किट विच कितना करंट फ्लो करना है वो डिपेंड करता है इस सर्किट की रजिस्टेंस उत्ते। जे आपां एक बल्ब लगाया होया इट मीनस इस दे विच ज़्यादा करंट फ्लो करेगा। सिमिलरली जे आपां इत्थे दो बल्ब अटैच कर देवांगे दैन द रजिस्टेंस ऑफ द सर्किट विल इंक्रीज, सो देयर बाय दिस विल डिक्रीज द फ्लो ऑफ द करंट इन द सर्किट. Now what is the unit of current? Now current is measured in amperes, or it can be written as amps or A in the short. Now 1 ampere is a flow of a certain quantity of electricity in 1 second. So the amount of the electric current entering a circuit always equal the amount exit the circuit. Means whatever the quantity of current entering the circuit, that must be equal to the current that is leaving to the circuit. Now next is the direction of conventional current. Now conventional current was proposed by Ben Franklin in the 70s. The scientists later discovered that the particles that carry electricity in a wire actually travels from negative to the positive. Means the basic mean is that the electrons travel from the negative terminal to the positive terminal, thereby the direction of the current is the opposite to the direction of the flow of the electrons. So if the electrons flow from negative terminal to the positive terminal, therefore the direction of flow of the conventional current is from the positive terminal to the negative terminal. Means we can say that the direction of flow of the conventional current is opposite to the direction of flow of the electrons. Now next is voltage and its units. Now, voltage is the measure of electric potential energy, just like height is a measure of gravitational potential energy. Now voltage is measured in volt, and 1 volt means 1 ampere of current does 1 joule of work in 1 second. So this is now this is the higher potential, the end at higher potential. Now this end is at lower potential. Now because of this potential difference, the current will flow in the circuit from the from the higher potential to the lower potential. So mind it, current always flows from the higher potential to the lower potential. The next is power is defined as the amount of energy consumed per unit time. So since 1 joule per second is a watt, and we can interpret voltage as measuring the available electric power per ampere of the current that flows, that is P is equals to V upon I. Means with the determination of voltage and current in the circuit, we can determine the power of that circuit. Now voltage can be measured by using the voltmeter, and the current can be measured by using the ammeter. Now suppose there is a one battery of 1.5 volt. Now we can say that the positive terminal is at 1.5 volt, whereas the negative terminal, which is at lower potential, now the voltage here is 0 volt. So the positive end of 1.5 volt battery is 1.5 volt higher than the negative end. Now if we connect one more battery to this single battery, then the total voltage will become 3 volt. 1.5 volt plus 1.5 volt, it is 3 volt. So the upper end is 3 volt and the lower end is 0 volt. And again if we connect 3 batteries, the total voltage, the positive voltage will becomes 4.5 volt, and similarly the lower voltage will remain the same, it is 0 volt. So we can say that if we connect the batteries in series, then the voltage is adding one to each other. Now next is how we can measure the voltage of a cell. So suppose this is a cell and we are using the multimeter. So this is a knob which we can vary according to the calculation. Now suppose now we are checking the voltage. So this knob is directing to the voltage terminal. See, this is the voltage. So set the voltage to the meter to the DC volt. Now touch the red, now this is a red lead, touch the red lead, that is the positive lead of the meter, to the positive terminal of the battery. So this is the red lead which is connected with the positive terminal, and touch the black, that this is a black lead which is negative lead, and connect this lead to the negative terminal of the battery. So with this we can calculate or measure the voltage of a cell. So if we want to measure the voltage in a circuit, so in this way we can measure. The same procedure is there, but we have but do not disconnect the circuit. Now how we can measure the current? The same, by using the multimeter, but simply changing the knob to the ampere, terminal ampere. Now in practical electricity, we still label current flowing from plus to the minus or high voltage to the low voltage. So current cannot be measured unless the charges flow through the meter. Means we can say that if we are using a conductor here, then the current will flow only if the charge will move. Now see, current is basically a flow of the charge. So this is a battery Now how the current will flow from the positive terminal to negative terminal, see. The next is electrical resistance and Ohm's law. Now because the conductors, we are discussing the topic the conducting materials. So the conductors are those material through which the electric current pass very easily. But still we have to discuss the resistance, the main topic resistance, and then the Ohm's law. Now the German physicist George S. Ohm experimented with circuits to find the exact mathematical relationship present in most circuits, and according to that Ohm's law, V is equals to IR. Now Ohm's law is basically the product of current and resistance in a circuit. So it can be used to predict any one of the three variable if given the other two. Means if current and if voltage and resistance of any circuit is given, then we can calculate the current flowing through that circuit very easily by using the Ohm's law, because according to Ohm's law V is equals to IR. So V is 1, R is 1, and current is equals to V upon R. So 1 upon 1 is 1 ampere. So current is 1 ampere. So this is a current, I is current, V is voltage, R is the resistance, which is measured in ohms. So if we know voltage and resistance of any circuit, then the current is given by V upon R. Now if current and resistance is given, then we can calculate the voltage by using the relation V is equals to IR. And similarly, if voltage and current is given to of any circuit, then by using this relation R is equals to V upon I, the resistance of that circuit can be calculated. Now see, this is a simple circuit in which a battery is connected with a 2 ohm resistance. Now calculate the current flowing through the circuit. Now here given is voltage and resistance. So the current can be measured by using the relation I is equals to V by R. So it is 1.5 by 2 volts. Now next is electrical resistance. So see, these are the two jars. Is the nozzle, जो first jar है, is the जिहड़ी nozzle है, now this is very thin, जिहड़ा passage है पानी वास्ते बहुत ही घट है, but for this jar the passage for the water is wide. ठीक है, it means resistance measure how difficult it is for the current to the flow. Means here the current is low, therefore the resistance is very high, but in this circuit the resistance is very less and the value of current is very high. Means we can say that resistance and current are both are. The next is the resistance. The degree to which a substance opposes the flow of electric current through it is known as a resistance, and all substances resist electron flow to some extent. Now resistance for the conductor, if we see, the conductors such as metals allows the electron to flow freely through them and have very low resistance values. So if we are discussing the conductors, semiconductors and insulators, now for that, now for the conductors the value of the resistance is very less, as the electrons can move easily from one place to another place, while in case of insulator the resistance is very high, because the electrons cannot move freely from one place to the another place. So see, this is this upper shows the the green, this is a conductor in which the electrons flows very easily from one place to the another place. Now this is a insulator in which there is a much difficulty for an electron to flow from one place to the another place. Now resistance is measured in ohms using, and it can be measured by using the ohm meter, and ohm meter is a device which is used to measure the resistance, and it is always connected in parallel. And to measure the resistance, set the knob of the multimeter to this ohm direction. Now set the black and red leads and opposite ends of the object. So by this we can measure the value of the resistance. So when a substance resists the flow of electrons, it slows down the current and converts the electrical energy into other forms of energy. So the more resistance a substance has, the more energy gained by the substance is radiated to the surrounding as heat or the light energy. Now a resistance in any material can slow current. Now in a light bulb, the filament high resistance to the electrons electrical energy causes it to heat up and produces the light. So this bulb is a resistive load. So whenever we connect this load to the circuit, ਜਿਹੜੀ ਇਸ bulb ਦੀ resistance है, that will resist the flow of current from one terminal to the another terminal. So with this resistance, that current ਜਿਹੜੀ power है, that will converted into the light energy, or you can say the heat energy. So in this way the electrons ਜਿਹੜਾ bulb है ਉਹ गर्म हो जाता है ਤੇ ਉਹ light produce करता है. Now resistors and potential difference. Now resistors can be used to control current or potential difference in a circuit. Now in any circuit, electrons have a higher potential difference as they enter a resistor compared to when they leave the resistor, because they use up some energy in passing through the resistor. So again this is a battery and this is a circuit. So the current is flowing from the higher terminal to the lower terminal. According to the Ohm's law, I can be calculated by using the relation I is equals to V upon R. So potential difference is the difference at the both ends of the terminal. So for this battery, the upper end is at high potential and the lower end is at lower potential. So this difference between the two terminal is known as potential difference. Now example, imagine electrons entering a resistor as being at the high end of the ramp. So this is a electron, इथों enter करेगा from the high end of the ramp where they have a lot of potential energy. So at this end, these electrons have a maximum potential energy. So in this analogy, electrons leaving the resistor are at the bottom end of the ramp. So इस resistance तो जब electron ने बाहर जाएगा, now this will at this position. So at this position, this electron have minimum potential energy. Now this potential energy has been converted to another form. So when this electron comes from higher end of the ramp to the lower end of the ramp, then this high potential energy will converted into low potential energy. So this energy will convert into the heat in the form of heat or in the form of light. Next is the types of resistors. Now resistors can be made with the number of techniques and materials, and the two common types are wire wound resistors and the carbon composition resistors. The first is wire wound resistors. A wire wound resistor has a wire made of heat resistant metal wrapped around an insulating core. The longer and thinner the wire, the higher the resistance. They are available with values from 0.1 ohm to 200 kilo ohm. So mind this line, the longer and thinner the wire, higher is the resistance. So we know that a resistance can be related to length and area by using the relation R is equals to rho L by A. Now if length of the wire is large and it has small cross sectional area, now for that the resistance of that wire is very high. The next is carbon composition resistors. The carbon composition resistors are made of carbon mixed with other materials. The carbon mixture is molded into a cylinder with a wire at each end. So ये कार्बन ਨੂੰ ਆਪਾਂ ਬਾਕੀ ਕੰਪੋਜੀਸ਼ਨ ਦੇ ਨਾਲ ਮਿਕਸ ਕਰਕੇ ਇਹਦੇ ਨਾਲ ਆਪਾਂ ਵਾਇਰਸ ਨੂੰ ਅਟੈਚ ਕੀਤਾ ਹੋਇਆ ਹੈ. By varying the size and composition of the cylinder, manufacturers produce resistance from 10 ohm to 20 mega ohm. So molded carbon resistors are cheaper to make than wire wound resistors, but it is less precise. So resistance in a wire, let us compare it with water to the electricity. So see, this is एक टैंक है जिहदे विच दो तरह दी पाइप्स ने. एक पाइप है जिसका जिहड़ा एरिया ऑफ क्रॉस सैक्शन है बहुत ही घट है, तो दूसरी पाइप है जिसका एरिया ऑफ क्रॉस सैक्शन बहुत ही ज़्यादा है. सो सी फॉर द स्मॉलर एरिया, इस थोड़े एरिए वाली पाइप वास्ते जिहड़ा पानी आ रहा है इसकी क्वांटिटी बहुत ही घट है. सिमिलरली इस ज़्यादा एरिए वाली पाइप दी जिहड़ी पानी जिहड़ा आ रहा है बहुत ही ज़्यादा है. So we can say that for the smaller area of cross section the resistance is high. resistance इत्थे ज़्यादा है इसलिए जिहड़ा पानी इत्थे घट आ रहा है. सिमिलरली इस पाइप दे विच जिहड़ी resistance है घट है इसलिए जिहड़ा पानी दी जिहड़ी क्वांटिटी है बहुत ही ज़्यादा आ रही है. So in this way we can correlate the water with the electricity. So longer thinner pipes have more resistance to the flow of water than pipes with a larger diameter. So resistance is inversely proportional to area. If area is less then resistance will more, and if area is large then resistance will be less. The more resistance that you have in a circuit, the more it will decrease current at a given potential difference. So if the value of resistance is high, then obviously the current will be less in the circuit. So larger shorter wires provide less resistance for the electrons to the travel, and the temperature and material can also affect the resistance. So resistance is a main factor for the conducting material. If the value of the resistance is high, then the conductivity of that material is very less, and obviously if the resistance is less then the conductivity of that conducting material is very high. The next is the factors that affect the resistance of a wire. Now first is the material. Now which material we are choosing for the conducting material. The first is the silver. Now silver is the best conductor, but we cannot use this material in a wire because it is very expensive. So instead of this silver we use copper for the wires because it is also a very good conducting material. So silver has the least resistance but very expensive to use in the wires. That's why we cannot use silver as a conducting material. Now most the conducting wires are made from the copper because this is not very expensive and it can be used in manufacturing of the wires. The next factor which affect the resistance of the wire is the temperature. Now as the temperature of the wire increases, its resistance increases, means with the increase in the temperature, the conductivity of the material decreases. So in other words, a colder wire is less resistant than the warmer wire. Means जे अपने कोल दो तरह दी वायर्स ने, एक कोल्डर है और एक वार्मर है, उन्हां विचों जिहड़ी कोल्डर वायर है